So last week we introduced a polar coordinate system, and a polar coordinate system was just the idea that any point could be represented as a radius from a point called the pole and an angle between that radius and a polar axis. So we could write any point using this r theta notation, and this allowed us to graph on circles instead of rectangles. What we didn't do any of last week, what we want to get comfortable doing, is converting back and forth between this r theta notation, our polar coordinates, and our old school rectangular coordinates. How do we go from r theta to xy? So that's what we're going to look at today, going back and forth between polar and rectangular. We're going to start by going from polar to rectangular, from the new stuff to the old stuff. So something that maybe you remember from the trig unit, x is our cosine values. However, in the trig unit, we frequently were talking about a unit circle, something with a radius of 1. So we often didn't have to worry about this r. But now that we're talking about polar coordinates, you can have an r value of 2 or 25 or 2,000, so that becomes a multiplier. So to get our x coordinate, we need to know r, and then also the cosine of that theta. So same thing with y. Y is sine values, but once again, we need to multiply by r. So to go from polar into rectangular, we need r cosine and we need r sine. Not too bad. We take a look at a couple examples here. My r value in a polar coordinate is just that first number, and my theta value is 5 pi over 3. So if I want to convert this to rectangular coordinates, well, x is r cosine, y is r sine, and we're just substituting in the values we need. R is 2. And then in order to get cosine of theta and sine of theta, you could use a calculator if you have a calculator that can spit back those nice fractions for you. Or you can jump back to a unit circle. I found this one on Google. If you don't still have a paper copy, just Google the word unit circle. You'll find something. I like this one because it has tangent values for us as well. 5 pi over 3. Down here. 5 pi over 3 then has a cosine value of 1/2 and a sine value of negative root 3 over 2. So we have 2 times 1/2 and 2 times negative root 3 over 2. So not too bad for the first example. We have 2's that cancel for our x coordinate. That's nice. And also some 2's that cancel for the y coordinate. That gives us a negative root 3. So there we have it, x, y coordinates for that first example. So again, we started with polar, and now we have something in rectangular. So those 2 points would be in the same place if you put the origin on top of the pole. You took those 2 coordinate systems and stuck them together. These would be equivalent. Let's do one more, and I'll put the remaining 4 in their own separate video. Same idea. We have an r value and a theta value. So if I want to flip-flop back and forth between polar and rectangular, I can use this r cosine, r sine idea. R cosine comes first because those are our x values. And then we get our sine. In this case, our r is negative 6. I'm going to have some sign changes here. And the angle that I want is 3 pi over 4. So jumping back to our unit circle, 3 pi over 4 is right here. So the values that we care about for 3 pi over 4 are going to be plus and minus root 2 over 2. So the negative root 2 over 2 goes with x. Positive root 2 over 2 goes with y. We do still get some cancellation here, not quite as nice as the previous example. But note that I have a 6 on top and a 2 on the bottom. 6 divided by 2 is just 3. We also have negative times a negative, so that will make this a positive 3. And then over here for Second one, -6 on top. We got the 2 on the bottom. That'll be a -3. And we are good to go. Probably worth mentioning just real quick, if we were thinking about that -6, 3 pi over 4, if you were just going to sketch that real quick, that 3 pi over 4 as an angle would be approximately that angle. Didn't do a super awesome job there. But keep in mind then the 6 is negative, so I would go the opposite direction. So that is a point in the 4th quadrant. And if you take a look at our rectangular representation, we do wind up with a point in the 4th quadrant, an x value that's positive and a y value that's negative. So keep in mind, if you plot both the polar and the rectangular version of the point, you should wind up with 2 points in the same quadrant. If you graph them really accurately, they'll be the exact same point. You could put those 2 coordinate systems on top of each other and the points will line up. I know my graphing's not always that accurate, so using quadrants is one of the best ways to double check your work. You can just do a quick sketch and those points will match. So again, I'll put these 2 in their own separate video. If you would like to see more examples, I will upload the remaining 4 examples here as well. See you next time.